Okay, 7-4 is the remainder and the factor theorems. Yes, factor like your favorite F word in math. We're going to be factoring again today. Dang it, right? Okay, so the remainder theorem says if a polynomial, f of x, is divided by x minus a, then the remainder is f of a. Meaning, it's just my function evaluated at a. So it sounds a little crazy, but if I take some polynomial and I divide it by a factor, my remainder is if I evaluated the function or just plugged it in. That's what's left over. Okay? And I'll show you what I mean. So, synthetic substitution. We can use synthetic division to evaluate a function. Remember placeholders, it says. Okay, so remember way back in chapter 5, section 5.3, we were dividing polynomials, and we did a long division way, and we did synthetic division. And I said, don't forget how to do this because we're going to do it a ton. This is the time where we're going to do it a ton. So if you look there at number 1, it says if f of x equals 3x to the 4th minus 2x cubed plus x squared minus 2, find f of 4. Okay, how did we do that on your homework last night? How did we find f of 4 yesterday? We just plugged it in, right? That still works. You can still do that. Okay, so the other way we can do it is to use synthetic division. When we do synthetic division, the number in our remainder box is the same as that function value. Sounds weird, right? Let's try it and I'll show you. Okay, so remember when I do synthetic division, I have to have all of the exponents in decreasing order. If not, I need a placeholder. So I have a 3x to the 4th minus 2x cubed plus x squared. Do I have a plain old x? You can't see it because I pushed zoom in. Sorry. No, we don't have a plain old x, so we need a placeholder. Alright, so I have 3, negative 2, 1. I need my placeholder, and another negative 2. When we were doing synthetic division before, remember we were dividing by something like x plus 3 or x minus 3, and we flipped the sign, right? This time we're not going to flip the sign because I want to know what is my function actually doing at 4. Think about it as x equals 4. Okay, are you ready? What do I do first? Anybody remember? Bring it straight down, right? First guy just goes straight down. Then what? Multiply 4 times 3. Add. Okay, negative 2 plus 12 is 10. Numbers might get big, so if you want a calculator, grab one. I'm grabbing one too. Repeat the process. 4 times 10 is 40. Add 41. Ooh, I can do this one. 164. 164 plus 0 is still 164. This one I'd like to say I can do, but I can't. I can, I just don't. I'm choosing not to. Let's put it that way. $656. Add down 654. That means that f of 4 is 654. Should we try it in our calculator just to make sure, because that number seems a little bogus, right? Okay, let's do it. I'm just going to plug them in like we did before. 3 parentheses 4 to the 4th minus 2 parentheses 4 to the 3rd plus 4 squared minus 2. Moment of truth. Did we do everything correct? Oh my gosh, it worked. Okay, do you have to do synthetic substitution to find a function value? No. Okay, you don't have to. You can still just plug it in your calculator. If you need the practice doing the synthetic division, I suggest you just try it. The only thing is you usually end up with some pretty big numbers, right? We got 654, so make sure you're adding and multiplying correctly in your calculator. When we get to your homework, do I care if you just type it in? No, because we're just figuring out what that function value is. Does that make sense? Okay, questions on that first one? Okay, so this guy, I wanted to know what my function was doing at 4. So that's what they call the remainder theorem. We can use that synthetic division to use the remainder to evaluate the function. The factor theorem says if x minus a is a factor of the polynomial, if and only if, when I evaluate that function at a, I get a 0 in the remainder box. So these ones you have to do the synthetic on, because we're going to end up factoring our whole polynomial. So, if it's a factor, my remainder box will be 0. So on these ones, we have to do the synthetic, and we should get a 0 in the remainder box. Okay, so number 2 there says, show x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18. Then find the remaining factors of the polynomial. Okay, so we're going to start with our synthetic. I got a cube, I got a square, a plain old x, and my constant. Do I need any placeholders? No. Okay. So here I go. 1, 4, negative 15, negative 18. When we do this, it says show that it is a factor. We should get a 0 in our remainder box. If you don't get in a 0 in a remainder box, you've done something wrong. Check your multiplication and adding skills. Okay, now, this guy up here, it said evaluated at 4. So we put 4 in the box. But this one is a factor. So if x minus 3 is a factor, what do I want to evaluate the function at? Positive 3. So this is the one where I have to flip the sign. Does that make sense? Do you see the difference? This one I wanted to know when x was 4. This says x minus 3, so I have to set him equal to 3. So I need to flip this sign. Or equal to 0, excuse me. No, equal to 3. Okay. Bring the first one down. One times 3 is 3. Add down is 7. 3 times 7 is 21. Add down is a positive 6. 6 times 3 is positive 18. So a negative 18 and a positive 18 give me 0. Perfect. That's what I wanted. Okay. Now, when we were doing this before, remember these guys meant something, right? These guys were the coefficients of my depressed polynomial. Depressed meaning he was an x to the third power, but I've depressed him. He has now lost an exponent. So he was a third. These guys are now the coefficients, and I'm going to start with x squared. So this guy is 1, x squared. And I keep dropping them. 7x plus 6. The number in front of the remainder box is always a constant. Jillian.
Why do we have to put like the arrows back in for this one, but not the first one?
Okay, so on the first one, we just wanted to know what was happening at 4. This one, it said show that was a factor. So if we're just going to show it's a factor, we don't have to. The last part says find the remaining factors of the polynomial. So if it just said show it, we could say, okay, we got a 0 in our remainder box. We're good. Good question. But now we're actually going to find the remaining factors of the polynomial, and we're going to finish factoring this guy out. Eventually, we're getting to the point where I'm going to say, okay, Jillian, here's this equation right here. Go find all 3 of its solutions. And that's it. That's all I'm going to say to you. Okay? So we're working towards getting to the point where we can find those 3 solutions. Good question. Okay, so now we're going to factor this guy. Maybe we should do this. All right, let's do our sign chart. Oops. Okay, here's my sign chart in case you need it. So I got a plus and a plus. So when I factor it, it'll be a plus and a plus. You need 2 numbers that multiply to 6. Signs are the same, so they add to 7. 6 and 1. We could solve it from there if it asked us to, but it said just find the remaining factors. And so when you write it with the x, that's factor form. Does that make sense? So this is a factor, this is a factor, this guy is a factor. Meaning if I multiplied all 3 of those guys back together, I should end up with x cubed plus 4x squared minus 15x minus 18. Which you've done before too. Okay, ready for another one? Okay, number 3 says the volume of a rectangular prism is given by x cubed plus 7x squared plus 2x minus 40. Find the missing measures. So you have to use the picture. What factor did they give us? X minus 2, right? So, do we need any placeholders? No. 1, 7, 2, negative 40. We should end up with a 0 in our remainder box. What number is going to go in my little box on the left? A positive 2. times 1 is 2. Add down. It's 9. 2 times 9 is 18. Add down. It's 20. 20 times 2 is positive 40, so we did indeed get 0. Started out with an x cubed. I've depressed my polynomial. I've divided one of the exponents off, so now I'm left with x squared plus 9x plus 20 equals 0. Okay, see if you can factor that. So, what two numbers multiply to 20 that add to 9? 5 and 4. All right, questions before we do the last one? Okay. Number 4 says given 2x cubed minus 5x squared minus 28x plus 15 and its factor x minus 5, find the remaining factors of the polynomial. Okay, do I need a placeholder? No. Alright, so I have 2, negative 5, negative 28, positive 15. Guess I don't need really that positive there. Should end up with 0 in our remainder box. What goes in my box on the left? Positive 5. Bring the first one down. This guy's a 2. 5 times 2 is 10. Negative 5 plus 10 is positive 5. 5 times 5 is 25. Negative 28 plus 25 is negative 3. 5 times the negative 3 is negative 15. So we did indeed get 0 there. So my depressed polynomial is now 2x squared plus 5x minus 3. Okay, so my signs were a plus and a minus, so it's going to be a plus and a minus. Don't forget that we need to put a 2 in both of them. And then we're going to multiply the first and the last. So 2 times 3 is 6. I need two numbers that multiply to 6. The signs in the parentheses are different, so they subtract to give me 5. 6 and negative 1. But I've now put that 2 in there too many times, so take it out and throw it in the trash. These guys have a 2 in common. So my factor is x plus 3. And then 2x minus 1. Yes, Hannah. So be careful because yes, you can. So you can put that there if you want. I'm not so concerned about all of that. Does that make sense? So yes, technically I probably should have put a negative there, but as long as you get the signs right down here, I'm a happy lady. Yeah. Any other questions? Jillian.
What is the box talking?
So what that's just saying, let me go up here. If I have a function and I'm dividing it by something, x minus a or something like that, my quotient is what's left over. So, for example, like this guy. If I have my function and I divide it by x minus 2, this is my quotient. Quotient, divisor, and then this guy has a remainder of 0. Does that make sense? So for one like this guy would be my function q of x. I'm dividing it by x minus 4, and I'm left over with 654. Good question. Okay, anything else? Okay, turn the page because that should be your worksheet. So this should go really fast. Holy cow. The first 4 at the top, you're just evaluating the function. I don't care what method you use. Okay, it says evaluate the function at the given value. If you want to plug it in your calculator, plug it in your calculator and tell me what it is. Okay, you don't have to show me any work. If you want to put it into your calculator and look at the table and then get your value from your table, you can do that like we did yesterday. If you want to do the synthetic, your remainder box will be your answer. Okay, like I said, the method is up to you. Even on your test, your method will be up to you. Down at the bottom, starting with 5, you're going to need to show me some work. The answer key only has the factors, but this is where you have to show me your work and do the long division. So you're going to do your synthetic division. Remember to flip the sign. And then you're going to factor. Okay? I think it's only one-sided. Let me double check. Yes. Okay, any other questions?